This works in the case when we have, first of all, three sides. Okay, when you have three sides, you definitely can't use the law of sines because the law of sines requires at least one angle. Okay, it also works in the case of side angle side. So that means you have two sides and the angle in between of them. Because you don't have that case with the law of sines where you have the angle across from this side. So similar to the law of sines in that we can pick different pieces, here is what the law of cosines looks like. It starts out looking like the Pythagorean theorem. A squared is equal to b squared plus c squared. I kind of mixed up the letters there. Okay, but then it's got this extra stuff to it. Minus 2bc. Notice that's the same letters that were on that side of the equal sign that were being squared times the cosine of angle A, the angle of the side that's on the other side of the equal sign by itself. Technically, there are three versions of this. It just moves the letters around depending on technically which ones you were given. It doesn't change. You can label these with anything that you want to. It's still the same formula. So it could also be b squared is equal to a squared plus c squared minus 2ac times the cosine of b, and it can also be c squared is equal to a squared plus b squared minus 2ab times the cosine of c. So again, if you just remember it as it starts like the Pythagorean theorem, and then I subtract 2 times the two legs that are on that side of the equal sign times the cosine of the angle that's on the other side, that's kind of how it's formed every time. All right, so let's look at some examples here. Finding sides. Okay, if we have 23 and 9 for side lengths and the included angle is 71 degrees, then we're going to set this up, since the side that we want is across from that angle, then we are going to set it up so that x squared is by itself. Now, the order of 23 squared and 9 squared doesn't matter because you're adding them together. Minus 2 times 23 times 9 times the cosine of the angle opposite the side that's by itself on the other side of the equal sign, so 71 degrees. Now, this one's pretty easy. We just need to punch all that into our calculator all at one time. You don't, I mean, technically you can split it up, but you don't really want to. Make sure you're still in degree mode from earlier and put all that in together. Cosine 71. Now, is that side x? 475.215. That's x squared. Okay, so we have one more step. We do need to square root that number. And we are going to round to the nearest tenth. So we'll go with 21.8. They didn't give us any units on this one, so we'll just leave it as 21.8. All right, number 2 is just like number 1, so I'm going to skip that one. Let's look at number 3. In triangle ABC, so we need to set this one up. The measure of angle B is 106 degrees. AB is 10. BC is 7. We want to find AC. So really this is the same as what we just did a minute ago. We just had to set up the picture this time. So same thing, x squared is equal to 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of the angle across from the side that's by itself. So 106. One of the really good things about the law of cosines is that we don't have to worry about multiple solutions like we did with the law of sines. Now, it is still possible to have no solution, but we really don't have to worry about that no solution scenario, or that two solution scenario that we had with the law of sines. So if we square root this one, we get approximately 13.7. Again, no units, so we'll just go with it like that. Okay, so the law of cosines formula is a little complicated, but in terms of solving, pretty simple. All right, let's look at finding an angle. So look at number 4. Find each missing measured round, all answers to the nearest tenth. Okay, so on number 4, we have all three sides, and they're asking, or all three sides, and they're asking us for this angle right here. So the side that is across from it needs to be the side that is by itself. So 8 squared is equal to 11 squared plus 10 squared minus 2 times 11 times 10 times the cosine of, we don't know that angle. That's what we're solving for here. Okay, now you gotta be careful with these. We are gonna have to break this down and solve it in a few more pieces than the other one. So 8 squared is 64. 11 squared plus 10 squared is 221. 2 times 10 times 11 is 220. Now, here's where people make the mistake. And I'm going to erase my cosine, and I'm going to put that times back in there. I've been doing a pretty good job of showing that multiplication. Technically, you really don't have to show that multiplication between the 220 and the cosine. You can just write that as 220 cosine. But I want to put that multiplication there just to remind you that these two things, the 220 and the cosine, are a single term. They go together. I emphasize that because a lot of people want to do 221 minus 220 right here and just get one cosine. That's not what happens. Okay, if we are solving this, our next step is to subtract the 221. So negative 157. And then since we have negative 220 times the cosine of x, then we turn around and divide by negative 220. And I don't really want this in a decimal right now, so I want to keep it in fraction form. It doesn't reduce, so we're just going to, the negatives cancel. So we're going to leave it as 157 over 220. That's equal to the cosine of x. We're solving for x, so we need to do the inverse cosine of 157 over 220 for our angle x, and we get 44 point, I wanted us to round to the nearest tenth, so 44.5 degrees. Don't start getting lazy on me and leaving your degrees of law. Okay, you need to be clear that that is an angle and not one of your side lengths. Now, we can't fully check this unless we do a whole bunch more work with the law of sines to find another angle, but we can kind of use a little bit of logic. 8 was the shortest side, 44.5 degrees. That is a smaller angle, so it kind of makes sense that that would fit in the problem.